before drawing the graphs of some functions, you must know the definition of even function and odd function. Even function. For even function, f of minus x must be equals to f of x. Now what does this mean? For example, you have f of x is equals to cos of x. Then f of minus x, replace x with minus x. And you know the property of cos x, cos minus x will be equals to cos of x. So you see f of minus x is equals to f of x. So this shows that this f of x equals to cos of x is an even function. In even functions, graph of f will be symmetric. Graph of f will be symmetric about y-axis. Now, what is an odd function? For odd function, f of minus x must be equals to minus of f of x. For example, if you have f of x is equals to x cube, then f of minus x will be equals to, replace x with minus x whole cube. This will be equals to minus of x cube. Now you see f of minus x is equals to minus of f of x. So this function is an odd function. Now in odd functions, the graph of f is symmetric about origin. Symmetric about origin. Now, these are the coordinate axes. This is x-axis. This is negative of x-axis. This one is y-axis. And this one is negative of y-axis. The point where both the axes are cutting each other, that is called origin. That point is called origin, and it has coordinates 0, 0. Now, to draw the basic functions, to draw some basic functions, for example, y is equals to x square. This y is basically f of x. If I want to draw the graph of y is equals to x square, you know that this function is an even function. Its graph will be x square. This is the graph of x square, half. Now this is an even function. So for even function, f will be symmetric about y-axis. This is y-axis. So it will be symmetric about y-axis. Symmetric about y-axis. Second function, y is equals to cos of x. Now cos of x is again an even function, so its graph will also be symmetric to y-axis. See, same behavior around y-axis. Now third example is y is equals to x. Now y is equals to x is an odd function, so it will be symmetric about origin. Symmetric about origin. The behavior it is showing here, the same behavior will be shown this side. So it is symmetric about origin. The fourth example, y is equals to x cube. Now this is again an odd function, so its graph will be symmetric about origin. Y is equals to x cube. So it will be like this. Now, example number 5. Y is equals to x raised to power 2 over 3. Its graph will be, since this is an even function, so its graph will be symmetric about y-axis. Now, example number 6. Y is equals to x raised to power 1 over 3. Since it is an odd function, so its graph will be symmetric about origin. Seventh one is y is equals to absolute value of x. Even function, so its graph will be symmetric about y-axis. Now the eighth function, y is equals to 1 over x. That will be symmetric about origin since it is an odd function. Ninth example, y is equals to sine of x. Since it is an odd function, so its graph will be symmetric about origin. Now, if we analyze from the start, our first example was y is equals to x square. So we will draw it like this. Then y is equals to cos of x. Then y is equals to x. Then y is equals to x cube. Then y is equals to x raised to power 2 over 3. Y is equals to x raised to power 1 over 3. Y is equals to absolute value of x. Y is equals to 1 over x, and y is equals to sine of x. In the next video, I will show you the translation, the concept of translation for drawing these graphical functions. For more videos and updates, like and subscribe the channel. Thank you.